Okay, once more, we're going to do question 2, and I hope every one of you've watched the video for question number 1. We are through with question number 1, we're going to question number 2. Don't forget to like this video, share this video, comment if there's any place you're having difficulty or that is not properly explained to you. You can comment on the video and I will get back to you. Now, question number 2. It says the velocity v of a wave in a stretched string depends on the tension T in the spring and the mass per unit length mu of the spring. Obtain an expression for V in terms of T and mu using the method of dimensions. Using the method of what? Dimensions. Okay, to solve this, we're going to first of all start by analyzing the question. It says the velocity V of a wave in a stretched string depends on the tension T in the spring and the mass per unit length mu. So this is what we're going to do. We're going to be using the principle of proportionality because of that word depend. So velocity is proportional to the tension and the mu of the string. So that's what we're going to start with. And using the method of dimension, it simply means we're going to, first of all, we're going to introduce our unknown powers. I can decide to use t raised to power x and mu raised to power y, depending on what you want to use as your power. I can decide to use t raised to power a and mu raised to power b, depending on what you want to use. It's up to you. So I want to use x and y. So I could use t raised to power x and mu raised to power y. Now, remember the rules of mathematics. Whenever you're changing the proportionality sign to equal to, you must introduce a constant. So v equal, I must introduce a constant which is k. Then t raised to power x and mu raised to power what? Y. So this is actually what we're looking at, because they said obtain an expression for v in terms of t and mu using the method of dimension. So this is the key thing we're looking at. But for us to obtain a perfect expression, we need to know the value for the power of x and y. Now, the method of dimension, using the method of dimension. To use the method of dimension, it simply means on this left-hand side, this is velocity. And of course, we know the dimension for velocity is length. Let me use the dimension without wasting time. Length t raised to power what? Minus 1. Or I could as well write it in this format. Let's make it more concise. I could as well write it like this. L t raised to power minus 1. Please, you need to watch video 1 on this topic dimension so that you have better understanding how we got this. If you don't watch the video on this question 1, you might be lost here. So it's important you go there and watch it. So velocity, this is the dimension for velocity, equal to k. Now this is t. T is tension. Now also, what is the dimension for tension? The dimension for tension is this: mass, length, time raised to power minus 2. This is the dimension for tension. And remember, we have a power of x. Now, from the question, we know that this mu, this sign is actually mass per unit length. So in place of this sign, I'm going to be writing this word mass per unit length. And remember, mass, according to the first video I made, will be represented with m. And for length, it will be represented with what? L. So I'm going to put this to be m L raised to power minus 1. Why is it minus 1? Because of it says per unit length. So the length goes up and you have negative power. Then you put your y outside. Hope you can see my y because of the space. Now, I'm going to use these powers to open up the bracket. This m has a power of 1. This L has a power of 1. This m here has a power of 1. Then the rest have their own significant power being shown. Now here, this power here is 1. So I have L, 1, T raised to power minus 1 is equals to K. Now 1 times this X. Remember this X is, this bracket is here and then the X is outside. So I'm going to use this X to multiply all the powers. So M, 1 times X is X. L, 1 times X is what? X. Then you have your T. Minus 2 times this X is minus 2X. Then here, there's also 1. Here, 1 times this Y is Y. Minus 1 times this Y is minus Y. Now the next thing, I'm going to be using the law of indices. Those ones that are of same base, there's mass here, there's mass here. What is bringing them close is multiplication. So the power will become addition. So here will become, so this is what we're going to be doing before to apply the law of indices. This will become K, M. Since there's M here, there's M here. So we'll take one of the m, and what is bringing them is multiplication. So here become x plus this y. Then here we have L here, and we have L here. So we'll take one of the L. What is bringing them close is multiplication. So here is x. Then we have plus, open bracket, here is minus y. We have minus y. Then here is t. T is not having any other thing here to multiply it, so we'll just write the t the way it is. Okay, now the next thing we're going to do is to equate. Equating. I'm going to start by equating L. Equating L's. So here there's L here, and we have L raised to power 1 based on the dimension for velocity, which is equals to, here we have L as x. Now plus times minus is minus y. Then this L, since they are of same base, what we are left with is the power. So we have 1 is equals to x minus y. I can say let this be equation 1. Now also equating t's. Equating the t's, since we have t here and we have t here, let's equate the t. So here we have t raised to power minus 1, and here we have equal to t raised to power minus 2x. So let's say since they are of same base, we work with the power. So we have minus 1 is equals to minus 2x. Minus will take out minus. Now divide both sides by the coefficient of x, which is 2. So this 2 will take out this 2. So x is equals to what? 1 all over 2. Knowing that x is equals to 1 all over 2, we can easily find the y, since we have already gotten the value for x. Okay, so y becomes substituting 1 all over 2 for x in equation 1. And this is equation 1. Equation 1, we have 1 is equals to x minus y. So in place of x, I'm going to be writing 1 over 2. So we have 1 is equals to 1 over 2 minus y. So for y, since we're looking for y, I could decide that let me take minus y to this side and bring this 1 to this side. Now, the owner of this minus is y. So when minus y moves this, it becomes positive y. Then you have 1 over 2. Now, when this has invisible plus, when plus 1 crosses the equal to sign to this side, it becomes what? Minus 1. Now, there are different ways of making y to stand alone, but I just had to use this. Okay, so having this, y is equals to, now I'm going to do this, I'm going to put over 1 here. This is 2 and this is 1. The LCM between 2 and 1 is still 2 all over. 2 into 2 is 1. 1 times 1 is 1. Minus 1 into 2 is what? 2. 2 times 1 is what? 2. So therefore, y is equals to 1 minus 2 is negative what? 1 all over 2. Now this is the value for our y. Now knowing that this is the value for y and we have also gotten the value for x, we are then going to substitute it into that box. Remember the box that we had that I just erased. Let me bring back the box. Now the box we had v is equals to k t x and mu y. Now knowing the value for x and y, so x is 1 over 2, y is minus 1 over 2. So v will be equals to k t 1 all over 2 and mu is equals to minus 1 all over 2. Now this becomes our expression of v in place of what? T and mu. Now if for instance they ask you to make k the subject of formula, to put k, to make k to be an expression, what they are simply saying you should do is to remove this from here so that k will stand alone. So depending on the question, but for this question they said we should obtain an expression for v in terms of t and mu using the method of dimension. So I'm going to stop here, but if you want to find k, I think I'm just going to give everybody that as assignment. You do it and you paste it on the comment section, and in our next video I'm going to finish up this and tell you if you're right or wrong. Thank you. Do like and share this video and subscribe to this channel. Thank you. Till we meet again in our next class.